This is the first video for inverse functions, day 2. And in this video, we're going to look at composition of inverse functions. And we're going to make sure we understand why f of f inverse of x is x, and also f inverse of f of x is x. All right, so let's go back to our shoelace and climbing the stairs problems. So we're going to let the first function be f of x. So this is going to be f of x, and this over here is going to be f inverse of x. And I'm supposed to consider my input and output to f of f inverse of x. So f of f inverse of x. All right, so I'm going to do the f inverse function first. Well, if I'm doing the inverse function first, my shoes must have been tied. All right, so I'm going to have f inverse f inverse of tied shoes. All right, so I start with the input of tied shoes, and I do f inverse on that. I untie my shoes. So that means I have f of untied shoes. Well, now I do the function on my untied shoes. Oh, wait, now I tie them. And now I'm back to having tied shoes. All right, so I want you to see what happened. I started with tied shoes. I untied them. Then I tied them. And I'm right back where I started. So I start it with tied shoes. And I end it with tied shoes. Let's try that also with this one. So if climbing the stairs is f of x, and going downstairs is f inverse, and I am doing f of f inverse of x, well, my x here might be I'm starting on the second floor. All right, so f inverse, I go down the stairs. All right, so now I'm on the first floor. Now I'm on function f, which is climb the stairs. So I end up back on the second floor. So it turns out if I start at the second floor and I go down the stairs and then I go back up the stairs, guess what? I'm right back where I started. So here's another idea. The ones I did f inverse first, but even if I do f of x first, I plug in x and I do something to it and my output is f of x. But if I do the opposite, I end up right back where I started. So these are two rules you need to know, that f of f inverse of x equals x, which means if I start with something and I do two opposite functions to it, I end up right back where I started. If I started at x, I ended at x. And it doesn't matter which order I do it in, f inverse of f of x is also x. All right, so let's try this out on our table. I have my function a of x, and let's read off some of these. So a inverse of 8. All right, remember I'm doing inverse, so I look at the y values here. There's my 8. My output is 0, which in this case is an x value because I'm doing inverse function. I'm going from y to x. A inverse of 1, I look for my 1. There it is. I get a -3. All right, now these ones are going to be multiple ones, so let's start off with a inverse of 2. So a inverse of 2 gives me -2. And now I plug -2 into a. Wait a second, it took me right back to 2. That's what we were talking about before. Let's try another one. Here we have a of -1. So now this is, by the way, not inverse. So we're starting with a of -1. So a of -1 gives me 4. And now I do a inverse of 4. And that brings me right back to -1. So you see, my input and my output are the same because I am doing a composition of inverse functions. So we should look at this next one and we should be like, well, obviously the answer is going to be 4. And we can test it out. So let's go over here and test it out. A inverse of 4 takes me to -1. I plug -1 into A. I go right back to 4. All right, let's try this again. This time we're going to be looking at a graph. Now we really don't need the graph to see this, but I'll do it on the graph anyway. We should see that the answer here is going to be 1. but we'll do the in-between step. F inverse of 1, I plug in a y value of 1 and I get an x of 0. And so then I do f of 0, and f of 0 takes me back to 1. Same thing here, f inverse of f of negative 3. Well, if I start off with f of negative 3, so let's see, f of negative, here we go, no, there it is, f of negative 3. So let's see, if I plug in negative 3, I get negative 2, and then I do f inverse of negative 2, well, that gets me back to negative 3. Which goes back to the rule we wrote on the other page. If I have a composition of inverse functions and my input is x, my output is x. Same thing here, doesn't matter what order I do the inverse, I end up right back where I started. All right, so that means that if two functions are inverses, their composition equals x. So let's show that with this. It says show that these functions are inverse functions. So we're going to do f of g of x, and then we're going to over here do g of f of x. And in both cases, the answer must be x. All right, so let's try this out. So in this one, I'm going to have f, and my input is g of x, 1/3 x minus 2. And I'm going to plug that into the f function. So I'm going to have 3 times 1/3 x minus 2 plus 6. When I multiply this out, like so, I'm going to get 3 times 1/3, 1x, 3 times 2, minus 6, plus 6. We see that these cancel, and we get x. Look at that. We start it with x, we end it with x. Let's try it over here. G of f of x, my input is 3x plus 6. In the g function, I'm going to replace x with 3x plus 6. Now I'm going to distribute the 1/3. And when I take 1/3 of 3x, I get 1x. When I take 1/3 of 6, I get 2 minus 2. And 2 minus 2 cancels, and I get x. And notice again, my input was x, and after two inverse functions, my output was x.